Hello, boys and girls. Welcome back to another edition of Think Different Television. Now we're going to get into some more rigorous and complicated things to do with parallel lines and transversals. All right. So here's the first one. This is on your PDF that's attached. If you can't see it on here, copy it off your PDF. We have this picture, and we have the measure of angle 1, angle 2, angle 3, angle 4, all in algebra. Oh my goodness. We got to find x and y, okay? This is what we're going to do. They're the answers, so we're going to try and get those, because that's how we'd start. All right, now let us go to our notes. Parallel lines and transversals. We're going to do part 2, because now we're doing algebra. Ooh. Okay. So the first thing you do is you have to label your picture. So we have this and this. So this means that these two lines are parallel right here. And also you have this and this. So that means that since you have two marks here, these two lines are also parallel. We have two sets of parallel lines. Okay. So angle 1 is 3x plus 15. I'm just going to add that to my picture. You add that to your picture. Then I have measure angle 2 is 4x minus 5. I'm going to add that to my picture. Like that. Measure angle 3 is 5y. And measure angle 4 is 6z. I'm going to put an arrow to it because I can't fit it there. 6z plus 3. Like that. Okay. So now you got to find x, y, and z. So you can't put x and z or y. You can't put different variables in the same equation because, like, if you have this, if you have two variables in the same equation, what the hell are the answers? Is this 2 plus 2? Is this 3 plus 1? Is this 0 plus 4? You have an infinite amount of answers here, negative 1 plus 5, etc. So my goal here is to just get the, it looks like I have two x's, is get the x's together. Because once I have the x's together, then I can go from there. So I can solve for x first. So that's my first thing I'm thinking about, solving for x first. Then I'm going to get y, then I'm going to get z. So it's like a waterfall. Get x, then y, then z. Knocking down dominoes. So first I look at, okay, so x's are here and here, 1 and 2. And 1 and 2, what is that relationship? Well, what if I turn the paper? Yeah, if you turn the paper like this. And so I cover this part up because this part is not part of the problem. And so this is my transversal here. So yeah, it's part of the parallel lines, but it can also be part of the transversal. Because these parallel lines can form my automobile like that. So 2 and 1 are on the same side of the transversal, and I'm skipping this angle here. So what do we call that? Yeah, corresponding. And corresponding angles are congruent if we have parallel lines cut by a transversal. So that means that 4x minus 5 equals 3x plus 15 because these are corresponding and they're congruent. Okay, so sometimes it helps to reorient yourself. That's why it's good to write it down from your computer screen. So my first equation I'm going to create is that, because these are corresponding and congruent angles. Boom. Subtract 3x on both sides. Everyone solve it with me. 15 equals 1x, but I'm just going to put x, because 1 times anything is itself. And so add 5, last step. X equals, ding, 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 20. There you go. X equals 20. Was that what they had? Let's check. X equals 20. Oops, sorry. X equals 20. Got it right here. Okay, so now I got to find y. So we got x is 20. So now I'm going to find y. So, looking at this, y is here at angle 3. So if I know x, I can plug it in here. So that's going to be 4 times x, which we got was 20, right? Minus 5. 4 times 20, four $20 bills is 80. Minus 5, which is 75. So if I plug in the x I got here, angle 2 is going to be 75 degrees. And now what's the relationship between 75 degrees, angle 2, and angle 3? That's what I'm trying to figure out. Well, if I ignore this, these are parallel lines, right? So that means that this can be the transversal. So 2 and 3, same side of the transversal, skip this angle, skip this obtuse angle right here, and get 3. So 2 and 3 are corresponding again. Yeah, corresponding means congruent. Corresponding angles are congruent. So my next equation is going to be 5y equals 75. So that's going to be divided by 5. Y equals 75 divided by 5 is 75 divided by 5 is 15. Ding, 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 ding. Okay, is that what they got here? Let's check. Ba, ba, ba. Y is 15. Got it. Okay. So now let's get Z. So now, if y is 15, well, I know these are congruent, so 5 times 15, this is 75 also. Because if that's 75, that's 75. Oh, sorry, you can't see that, my bad. So if this angle is 75, this angle is also 75 because we already said that they are corresponding. So now Z is over here on angle 4. Okie dokie. So, what's the relationship between angle 3 and angle 4? Let's see. Oh, this one I may have to turn again. Let's turn, 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 like this. Okay, so I'm covering this up because 3 and 4 are on, these are parallel lines, and this is my transversal. Uh-oh, it's the same side of the transversal, and I'm not skipping one, because this angle is acute, this one's obtuse. This is consecutive interior. Consecutive interior are supplementary. So when I have consecutive interior angles, those are supplementary. So I have 75 plus angle 4 is 180. Supplementary angles add up to 180. Measure angle 4 was 6z plus 3. So I'm just going to plug that in there. 75 plus 6z plus 3 equals 180. Now we're going to solve. Combine like terms. 6z plus 78 equals 180. Whoop! Minus 78. 6z equals, solve it with me. What is that? Yeah, 102. Divided by 6. 102 divided by 6 is 17. There you go. So x is 20, y is 15, and z is 17 for all these. This is a complicated problem. This is one you may want to do again. You may want to cover this up and do it again and make sure you understand how to do the problem. You can do it on your own because there's a lot of stuff going on. Next, let's keep it going. Here you go. Next one looks like this. Number 1, let's look at it on the PDF. Number 1 right here. Okay, let's see what's up. Number 1. So sometimes they're going to put parallel lines and transversals in a different look for you. No problem. So I'm going to find x and y. So what I'm just going to do is I'm just going to extend these parallel lines and extend these parallel lines. Because what I'm actually looking at is when I have this situation, when these are parallel, they have to be parallel for all of those angle measures to be congruent. I'm looking for this situation because this is I'm really familiar with. This I can really get the alternate interior, alternate exterior. That's really easy and corresponding. So how can I recreate this in the picture? Oh, just extend these and then this right here. So this picture, let me highlight it a little bit. Right here and here and here is similar to this. This line right here is just there to mess with me. So this I'm just going to ignore for this problem. That's how they're trying to trick you. So they're putting an extra ish in there. We're not going to be tricked. No way. So now, ignoring this, here are the parallel lines. There's a transversal. So I have 5x and y. I can't put x and y in the same if I don't know them, same equation. But I can put x and x. So I'm looking at the x's first. So we have 5x minus 5 and this. So what is the relationship between these two angles? Oh, it's corresponding. Same side. You're skipping this angle with the y and you're going here. So it's this and this. So it's 5x minus 5 equals 4x plus 10 because they're corresponding, and corresponding angles are congruent when you have parallel lines cut by a transversal. Now let's solve. Subtract the lesser x. 1x is just x. X minus 5 is 10. Add 5. X equals 15. There you go. So now we got x, we got to finish the problem, we got to find y. So I'm going to plug in, because that's what we did last time, right, to find that angle. So you plug in here. So 5 times 15 minus 5. So 5 times 15 minus 5. That's going to be 75 minus 5, which is 70. So this angle is 70 degrees, and this angle is also 70 degrees. Because they're congruent, they're corresponding. I don't have to plug in there because I already know the answer because it's congruent. Now, what's the relationship between one of these angles and this angle? Well, they're consecutive interior, you could say, like we just did in the example, or they're along a straight line, right? So along this straight line here, and so they're also supplementary this way because they're a linear pair. So either way you think about it, whether they're consecutive interior or a linear pair, they are supplementary. So I got 6y minus 4 plus, because these two angles, or these two angles, so they both equal 70, so it doesn't matter. So 70 equals 180. So now I'm going to subtract 70. No, what did I do wrong? I didn't combine like terms first, right? 6y, 70 minus 4 is 66, is 180. Now I'm going to subtract 66. 180 minus 66. 6y equals 114. Solve it with me. Divided by 6, and you have y equals 19. There you go. So x is 15 and y is 19 for this problem. It's another one you might want to do again to make sure you can get it on your own without me. Because sometimes you just see it and be like, yeah, I got it. But can you do it on your own without my help? I don't know. So can you get 15 and 19 by covering it up and doing it again? That's a good strategy.